Hi, I'm Clay McKinney. This is Developer On-Ramp, and this video is just a brief introduction to how to count in binary and hexadecimal and bits and bytes, and why powers of 2 are so important in computers. So let's get into that. All right, now a computer in its core, its brain, the processor, is just millions of on-off switches, transistors. They can either be off or on. And if you want one of those switches to be off, you send it a 0. If you want it to be on, you send it a 1. And so the only two numbers a computer really understands deep down are zeros and ones, and that's binary. Now, the way that you count with binary is that after you use your two numbers, you go up to the next level, and I want to demonstrate that with Excel. All right, so we're going to start with 0, then 1, 2. I'm going to use autofill to count to 256. Actually 255. We started with 0. So 0 to 255. Just as a nice clean example. Now, so binary is going to count 0, 1, 1 0, 1 1, 1 0 0, and so forth like that. So in binary, so let's just convert equals decimal to binary of cell A2. Okay, and we will autofill that down. Actually, if I just double click it, it'll go. Okay, so 0 1 1 0 1 1 100, but it's not 100, it's 4, right? 1 0 0 1 0 1, right? And you see the pattern. And it's pretty interesting. You can actually, if you practice, you can do this on your fingers. At one point I practiced, but it's been a while. But you could say, for instance, 1, well, you start with 0. 0, 1, 2, 3, 4, 5, etc. Where each finger is either off or on, and you can count all the way to 32 that way on one hand. It's pretty fun. Or 31. This is 31. Okay, so that's how counting works in binary. Now, the thing about only having two choices, if you have one digit, you only have two choices. If you have two digits, you have four choices, right? 0 0, 0 1, 1 0, 1 1. If you have 3 digits, you have 8 choices. If you have 4 digits, you have 16 choices, 0 to 15. So 16 choices. So every bit that you add to is it creates another power of 2. So let's say we have 2, and 2 to the first is, let's see, that is J2 to the K2 power. 2 to the first is 2. We're going to make a bunch of 2's. I missed my handle. We're going to make a bunch of 2's. Okay. And for this one, we want to go up. So 2 to the first, 2 to the second. Okay. And then this is our answer formula. Let's go a little bit further to 24. Yeah, there we go. Okay, so these numbers are all just super important in computing because they're all even powers of 2. And when you're counting in binary, you know, if you have this many digits, you have this many choices. If you have this many digits, you have this many choices. So if you have 8 zeros and ones, you have 256 choices. If you have 16 zeros and ones, you have 65,000 choices. And if you have 24 zeros and ones, then you have 16.7 million choices. And these numbers, you see them all the time. All the time. Commodore 64. You know, my first computer had 128K of memory. You can buy, you know, if you buy a hard drive, it's probably going to be, you know, 256 gigabytes or a terabyte, or right? I mean, these numbers are repeated everywhere. I remember Excel, it used to have a limit of 65,000 rows on a sheet. You used to, back when we had processors that could only carry 32 bits of data in them, you had a hard limit of 4 gigabytes of RAM, right? I mean, these even powers of 2 just sort of rule the computer landscape. So 2, 4, 8, 16, 32. All right, so I hope you can, I hope that makes sense. Now, some other, another word I want to point out is if you have 8 bits, that's called a byte. And these are called bits. Bits are, you know, it's 1/8 of a byte, and that actually that's a really old word. You've heard the rhyme, 2 bits, 4 bits, 6 bits $1. All for our team stand up and holler, yay! Right? So 2, 4, 6, 8 bits. There's 8 bits in $1, right? Now we don't do that anymore. Our money is decimal now. But it used to not be. And that's a perfectly natural way to count. You know, you take something and you cut it in half, cut it in half, cut it in half again, you have 8s. You know, you have quarts, you have, all of these things. A lot of our measurements are based on 8s. So so each 0 or 1 is called a bit, and there are 8 bits in a byte, and let's see, there are, if you have 1,024 bytes, you have a kilobyte. And if you have 1,024 kilobytes, you have a megabyte. So we have bits, bytes, kilobytes, megabytes, giga, tera, right? And that's how we measure things. That's how we measure RAM. That's how we measure hard drive space. So that's where And that's where all these words come from. And that's why it's always 1,024 of this or 1,024 of that instead of an even 1,000. Because 1,024 is a nice round power of 2. You have 2 choices for every bit you have. So I hope that makes sense. You know, there's another numbering system that's used sometimes in computers, and that's hexadecimal. You don't see it a lot, but you do see it in when people talk about color on the internet. A lot of times they use hexadecimal notation to get at these 16.7 million colors that you can have. That's 8 bits for red, 8 bits for green, and 8 bits for blue. So that's 24 bits, and that gives you 16.7 million colors. And when people are talking about those colors, sometimes they use hexadecimal. The way hexadecimal works is, it means hexadecimal, you know, recognize that decimal is 10 and hex is 6. It's a 16-based numbering system. It goes 0 through 15. And so it counts 0 through 9 normally, and then it starts to use letters so that you can have 16 different digits, and then you use those over and over. So let me show you how that works. We're going to convert our decimal number to hex, and let's see, our first number, our decimal number is in cell A2. All right, and I'm going to double click our autofill handle to fill that out. So see how it goes: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 10. Right? And then, you know, 11 through 19, 1A, 1B, 1C, 1D, 1E, 1F, 20. It's very, very interesting. Okay, and we'll keep going. Let's see, this is about oh, by the way, I said that you had 8 bits red, 8 bits green, and 8 bits blue. And if you have 8 bits, you have 256 choices. So the choice goes from 0 to 255. So this is counting in hexadecimal from 0 to 255. So it counts from 00 to FF. Right? It went from EF to F0, F1, F2, F3, F4, F5. All right, so this is how hexadecimal works. And basically you can tell that it's nice to only have 2 digits instead of 8 digits. And that's the whole point of hexadecimal. It's a shorter notation. So if you had 2 hexadecimal digits for red, 2 hexadecimal digits for green, 2 hexadecimal digits for blue, you'd have 16.7 million choices with only 6 characters to type in. So that's pretty great. All right, I'm going to save this and upload it with the video. All right, thank you.